maximum value. Now, if you can quickly observe that 0, 0, if you substitute 0 in for x, you get 0 back for the entire expression, okay? Now, you can inspect this pretty quickly with numbers just to the left of x and just to the right of x, and you can see that this point corresponds to a local min. Now, that's not rigorous, but you can check it, and I mean, it's true. This point would correspond to a local min, that is x equals 0. Would correspond to a place where the graph is as small as it can be locally. Also, the graph does have horizontal asymptotes, which kind of leads to, makes you understand why we're talking about local rather than absolute. Now, so if x is not equal to 0, we can divide through by x squared, which is what happens on this very next step. We divided our given expression by x squared, nothing illegitimate because we're assuming that x is not equal to 0. We already know that corresponds to a local min, or at least I wave my hands on that. Now, notice that what I do right here, there's some interesting algebra that goes on here. Some people would prefer to do a substitution, but notice you can factor an 18 out of here. A lot of people might want to let's say y equals 1 over x and do it like that. I don't see any reason to make that substitution. I think the algebra is fairly clear. Let me show you what I mean by that. If you consider 1/2 plus 1 over x quantity squared, okay, when you square this out, when you expand this out, you do get 1/4, and you get, and I'll write this out, this is just straight from college algebra, plus 2 times 1/2. That's a step you're tempted to leave out, but it's nice just to see the structure here. Okay, 2 times, and I should put 1/2, I forgot that, didn't I? Okay, 1/2. Okay, plus 1 over x squared. So you see there, folks, when you expand this out, you do get the 1 over x squared term, and you do get the 1 over x term because the 2 and the 1/2 cancel, right? But you also get this 1/4 term, all right? Now, when you multiply through by 18, that gives you an 18/4 that you don't want. Okay, the 1 still stands, right? Okay, now 18/4 reduces to 9/2, and then 1 minus 9/2 is the minus 7/2 you see right here. Now, the big observation here, and the reason why we did all that, is minimizing the denominator maximizes the entire quotient, right? 19 is a positive fixed constant, right? So this expression, which is equal to our original object of interest, is, except when x is equal to 0, is going to be maximized when the denominator is as small as it can be, and that's exactly what this says. This quotient is maximized when the denominator is as small as it can be, and that's very clear that that'll happen when x is equal to -2. Okay. Okay, x equals -2 makes this whole part 0, and all you have is minus 7/2. That is, let me just write down what we get. You end up with, if you put a -2 right here, this part goes poof, and you have 19 divided by -7/2. Now back to grade school, dividing by a fraction is the same as inverting and multiplying. So that's equal to minus 38/7. Okay, and that's going to be our solution. Okay, again, based on this argument right here, this is going to be our maximum value, and it occurs at x equals -2. The question just asks for the maximum value, but this is the maximum. Okay, so yes, a negative number can be a maximum. The graph would probably look, something along these lines. I'm not sure really, actually, but minus 38/7 is down below -5, right? So we'll call this -5. And yeah, this is a very crude approximation, but it's probably something, it's below that, right? So, something like, I don't know, maybe like that. Who knows? Who knows? But it's as big as it can be in a certain region. Okay, it's not. We're not saying it's as big as it can be everywhere because we know the graph is positive in a lot of other regions. Okay, but anyway, I think that takes care of business for us. Um, and this may who knows what it is, but just in this region, that you would get that part of the graph would have as big a value as it could be. Let me write x equals -2 here just to make this slightly more credible. That would be x minus 2 right there, right? Okay. And it's as big as it can be somewhere below. I made it look like it's above -5, but it's below -5, right? Since minus 30 over 5 is less than -5. Anyway, y'all, this is the answer. Minus 30 over 5 meets the conditions of the problem without having to use calculus. Okay, so that local maximum value is minus 38 over 7. And I didn't rigorously show you that it's the only local max, but it's the only solution to this equation. And this thing does have horizontal asymptotes. Just calculus tells you, if you take the limit as x gets unbounded in both directions, you would get horizontal asymptote of y equals to 19. And so sometimes the graph does cross horizontal asymptotes. I don't think it does here. If it did, it could possibly go up and come back down and you would have another local max, but I don't think that happens, although I didn't prove that. But anyway, this is a local max. I tend to think it's the local max, but I only showed you it was a local max in the non-unique sense. Okay. All right, thanks for viewing.